Hello, in this lecture we're going to continue our discussion of describing supply and demand elasticities, chapter 6. Remember that our goals are to use elasticity to describe the responsiveness of quantities to changes in price and distinguish 5 elasticity terms, explain the importance of substitution and determining elasticity of supply and demand, relate price elasticity of demand to total revenue, define and calculate income elasticity and cross-price elasticity, and explain how the concept of elasticity makes supply-demand analysis more useful. Okay, so elasticity is not the same as the slope. So last time we calculated the elasticity of demand, and we noted that when we did the elasticity, it's not exactly the same as the slope of the line, because we're talking about percentage changes. However, it does relate to the slope of the line. So we know that the steeper the slope of the line, at a given point, the less elastic the demand or supply is. So we can think about, the slopeness of the line having some relationship to the elasticity. If we think about the extreme cases, then these are the two cases that probably will not happen in real life, but if we push our model to the wall, to the two extremes, these would be the two extremes. So this curve is perfectly inelastic, meaning that Q does not respond at all to a change in price. So whatever price is, the quantity is the same. So if the price goes down, quantity the same. Price goes up, quantity the same. Perfectly inelastic. No change. You can't pull the rubber band at all, no matter how much pressure put on it. Again, this probably isn't a practical thing in real life. There's not too many things that are completely inelastic. But these are things like, again, if there was that cancer drug or something that someone really needed, then theoretically you could change the price a lot. The level of demand would not change, at least not much. If we think the other extreme case, the curve is perfectly elastic, meaning that Q responds enormously to the change in price. So this is probably, again, not going to happen in real life, but we can think of the extreme, meaning that this is the only price you can charge in this case. If you put up any more, if you charge any more, people are not going to demand anything at all. And notice that's probably not, even of the extreme case, you'd probably think of as a very shallow line such as this. But if you think of perfect markets, then you think of something like selling the hamburgers or something like that. If we change our price at all, then people could go to somewhere else, or they could substitute in such a way, and that would be a product that has a lot of competition and substitution possibly that would lead towards a perfectly elastic curve such as this. So elasticity changes along the line curve. So one straight line supply demand curve stays constant, but elasticity changes. So if we think about the slope of the line, we know that the slope of the line is constant if we calculate the slope of a line. However, we know that the elasticity, the way we calculate it, because we're taking the change, is the percentage change, is actually going to change along the slope of the line. So when we think about that, then we can say that if we start up here and we did our elasticity calculation to be infinitely elastic, in this section here, we're saying if we did our calculation for elasticity, elasticity of demand would be greater than 1, meaning it would be elastic at this point in time. At this point here, it would be perfectly elastic, and down here it would be inelastic, meaning our calculation would be less than 1. And down here it would end up to be 0. So elasticity declines along the straight line demand curve as we move towards the Q axis. So let's take a look and see what this means graphically. So here's our same numbers plotted out. We've got the quantity from 0 up to 10, and we got the related price here. And we can see our demand curve. This is the same demand curve we just looked at. And if we did another thing, if we calculated revenue on this just to see how this is applicable, if we calculated the revenue, we'd have 0 times 10 is 0. We've got a quantity of 2 times 8 is 16. A quantity of 4 times 6 is 24. A quantity of 6 times 4 is 24. A quantity of 8 times 2 is 16, and 10 and 0 is 2. If we plotted that then, and we plotted the revenue here on the vertical compared to the price, then we can see that if we had a price of 0, then we'd get 0. And as we increase the price, we would think the revenue would increase up to a certain point. In this case, that point being between the 4 and the 6, where we're perfectly elastic. After we move from that point, then we're actually going to lose revenue if we increase the price. So we're increasing the price, but the change in quantity is such that our revenue will actually decline. So if we think about this, as the price increases, on this axis, the revenue will increase. And that's when the part of our demand curve is inelastic. So, and remember that on a straight line curve, we're going to go from one particular product that we're selling could be inelastic as part of the straight line curve, which would be related to the bottom half of the curve. Then it's going to be elastic towards the top half of the curve. So we're talking about one product. But remember, when we talk about the extreme type of product that could be inelastic, we're talking about things where you can change the price a lot and it has little effect on the quantity that would be purchased. Something like selling the drugs that someone needs for medical purposes, selling like cancer drugs or something like that. That's the extreme example in terms of a type of product. We're talking about one type of product going from their demand curve in the point of being inelastic and then stopping at some point up here where we're maximizing. And then of course, if we raise the price anymore in this case, the revenue is actually going to go down. So the revenue is going to go down from this point as we increase the price, because now we have entered the part of the curve, of the demand curve, which relates over here to where we are now elastic, meaning that the change in price has a greater change on the quantity demanded, which will actually reduce the amount of revenue if we increase the price more at that time. Remember, if we talk about an extreme good that would be inelastic, just as an example of a type of good that would be elastic, there would be things like hamburgers or something, where if we change the price, then there's going to be probably a greater change in the quantity demanded. Now we can think of the same type of elasticity calculation for different items as well, such as supply. So when price elasticity of supply is the percentage change in quantity supplied divided by the percentage change in price. Similar calculation, we won't go into it in as much detail, but same concepts here. We got the percentage change in quantity supplied divided by the percentage change in price, elasticity of supply. So this tells us exactly how quantity supplied responds to changes in price. So changes in price and quantity, and the quantity that will be supplied in this case, elasticity is independent unit. So here we've got our supply curve, which of course is sloping up. We've got the price and the quantity. Once again, we need our calculation once again. So it's the same calculation. If you want to take a look at how it breaks down, look at the same calculation we took a look at for quantity demanded, elasticity of demand. And we have the similar calculation. Just note that when we take the differences of these 2 points, that when we're taking the percentage change, we're taking actually the average of the 2 points in the denominator. So just keep that in mind. Take a look at the calculation when we calculated the elasticity of demand. If you have questions on that, you do probably want to write this out so that you can do it algebraically, do it one step at a time. All right, so elasticity changes along the straight line curve. So same idea, that we're not taking the slope of the line. The elasticity will change throughout the straight line because we're taking the percentage change. So how will it change? It'll start at either infinity or 0, and it'll increase and approach 1 as we move up, as we rise through the supply curve. So supply is elastic if the percentage change in quantity is greater than the percentage change in price. So elastic supply is when elasticity is greater than 1, and supply is inelastic if the percentage change in quantity is less than percentage change in price. So inelastic supply is when the elasticity is less than 1.